Hello student, today we are going to see the chapter number 10 that of the 10th standard, that is quadratic equation. We'll see the nature of the root. Nature of the root for the quadratic equation. We know that the quadratic equation is in the form of ax square plus bx plus c equal to 0. The root obtained, that is for the value of the x, is given by the formula, that is equal to minus b plus minus root of b square minus 4ac whole divided by 2a. If this term, this root term, this b square minus 4ac is greater than 0, then we have two distinct real root, that is minus b by 2a plus under root 2b square minus 4ac divided by 2a, and second is minus b by 2a minus square root b square minus 4ac divided by 2a. So these two distinct root we will be getting. Now we'll see what are the different natures of the root we are getting when we have in our quadratic equation. So suppose when, and mainly it is depend upon the value of b square minus 4ac. The nature of root depends upon the value of b square minus 4ac. So in our standard quadratic equation, ax square plus bx plus c equal to 0, when we have a three condition over here, this b square minus 4ac is called as determinant of the quadratic equation. That is the determinant of quadratic equation. So determinant determines the nature of the root. So first condition is that if b square minus 4ac is greater than 0, then we have two distinct real roots. Second condition is that b square minus 4ac is equal to 0. Then there are two equal root exist. Onto that. And suppose the b square minus 4ac, it is less than 0. So there is no real root exist. Onto that. We have to remember all these three conditions while solving our quadratic equation problems. Now let us solve this example where it has been asked that the nature of the root of the following quadratic equation if the real root exists. We are already given that the roots are the real roots. So condition is that our b square minus 4ac, the value of b square minus 4ac is always greater than 0 when the real root exists. So condition is that b square minus 4ac is always more than 0 when the real root exists. So let us solve this example now. So here in this example it is given as 3x square minus 4 root 3x plus 4. So if we compare this example with our ax square plus bx, ax square plus bx plus c equal to 0, then we will observe that a is equal to 3 over here, b is equal to minus 4 root 3, and c is equal to 4 over here. So this value we are getting. So now we need to check b square minus 4ac. Now b square minus 4ac is equal to, b square is minus 4 under root 3. So if I write minus 4 root 3 whole square minus 4 multiplied by a is 3 and again c is 4. So it gives me the value of 16 minus 16 multiplied by 3. So it is 48 minus 48. So it is 0. So that means the root exists if b square we had already saw that if b square minus 4ac is equal to 0, then we have two equal roots, two equal real roots. So we have a two equal real root. That means the roots can be written as x equal to, now this terms is 0, so it will be cancelled out. This is minus b by 2a, root is minus b by 2a, so we know b is minus 4 root 3 divided by 2 into a means a is 3, so here minus is plus, so it is, and 2 will get cancelled, so 2 1s are 2, 2 2s are 3, and this root 3 and root 3 from here will get also cancelled, so it become 2 root 3. So we have a x equal to 2 root 3 and 2 root 3. There are two distinct real root will be obtained over here. Next we'll see this problem where it has been asked to calculate the value of k for the following equation. So we know that this equation is given as a 2x square kx plus 3 equal to 0. So let's solve this problem. So here if we compare that, a value is equal to 2, b is equal to k, and c is equal to 3. If we compare it with the standard equation, so now if we find out the determinant, b square minus 4ac is equal to b square is k square minus 4 into 2 into 3. So that means k square minus 24 equal to 0. That means k is equal to root 24, or I can write it as a plus minus 2 root 6. So 4 6 are 24, and root of the 4 is 2, and it is root 3. It is 4 2 are 24. It is 4 it is a 4 6 are 24. 4 6 are 24. So root of the square root of 4 is 2, and square root of 6 is root 6. So it gives us the k is equal to, so k is equal to plus minus 2 root 6. So k is equal to plus minus 2 root 6. Let's see another example. Is it possible to design a rectangular park of the perimeter 80 meter and area is given as 400? So the perimeter, we know the rectangular park perimeter is p is equal to 80 meter, that is equal to p is equal to twice length plus breadth. Yes, this we know, and area also we know, length area is given as 400 meter square, so it is length multiplied by breadth. So from this equation we'll get the L plus length plus breadth is equal to 80 by 2. So I will take it in terms of length. This is 40 minus b. I can write his length as a 40 minus b. So I will put that length over here. That is 400 is equal to 40 minus b multiplied by b. So I will get the quadratic equation as 400 is equal to 40b minus b square. So here, and if I rearrange it, then b square minus 40b plus 400 equal to 0. It will give us like this. So here a is equal to 1, b is equal to minus 40,